All right, so we're on problem 19 here. It says determine if each function is a polynomial function. If it is, state its degree. Okay, so part A, we have f of x equal 5x cubed minus 2x plus 7. Now there's two things that we want to be looking for in order to call something a polynomial. Okay, and a polynomial is where you're adding up a bunch of stuff here, but there's two things that you got to be looking for also. The first thing is that every single coefficient has to be a real number. Okay, so you're not doing anything with imaginary numbers. We'll talk more about that in chapter 4. Okay, and then the second thing is every single power of x has to be a whole number. Okay, so a whole number is a number of the form 0, 1, 2, 3, etc. Okay, so let's check this. So the first thing is every single value in front of each term a real number. Well, 5, negative 2, and 7, those are real numbers. And then the second condition is every single power of x a whole number. Okay, so 3 and 1, those are examples of whole numbers. So this is a polynomial. Okay, the degree of the polynomial is just the highest power of x that we see. Okay, so this would be a degree 3 polynomial. Okay, in part B, we have f of x equal 2x to the fourth minus the cubed root of x. So this is not going to be a polynomial because the cubed root of x is the same thing as x to the 1/3 power. Okay, and you can't have fractional powers for when you're talking about polynomials. So it can only be whole number values. Okay. Now I would not say that this is a polynomial degree 4. Okay, it's just the whole thing is not a polynomial. Okay. Part C, we have g of x equals 1 divided by x squared minus 7x plus 2. That's not going to be a polynomial because to be in polynomial form, you need to be adding up a bunch of stuff. You can't be dividing anything. Okay. Now, in some cases, if I had a division type situation going on, and let's say part of the numerator canceled with part of the denominator, and I ended up getting something. The form where I'm adding up a bunch of stuff there, then that is a polynomial. Okay, it's just no matter what we do with this guy, we're still going to have that fractional form there. Okay, so that's why it's not a polynomial. Part D, I got h of x equal 43. So is 43 a polynomial? Okay, well there's two conditions I got to check for again. So condition 1. Every single coefficient in front of x has to be a real number. Well, 43 is a real number, right? And then the second thing, every single power of x has to be a whole number. Okay, well, I don't have any x's. So that condition is checked off by default. This is a polynomial, and this would be a degree 0 polynomial. Okay, in other words, the highest power of x is 0. I don't have any x's. Part E, I have r of x equal x times 3 minus x squared squared. Is that a polynomial? Okay, well, I'm not in polynomial form yet, but maybe I can get into polynomial form. Like maybe I can get into the form where I'm adding up a bunch of stuff. So let's go ahead and FOIL out 3 minus x squared times 3 minus x squared. When I FOIL that, 3 times 3 is 9. Negative 3x squared minus 3x squared, that's minus 6x squared in the middle. And then negative x squared times negative x squared, that'd be x to the fourth at the end. And then if I distribute x into these three terms, I'd have 9x minus 4x cubed plus x to the fifth. Okay, and that would be in polynomial form there. Okay, I'm adding up a bunch of stuff. And every single value in front of each term is a real number, right? 9, negative 6, and 1. Those are real numbers, right? And every single power of x is a whole number. 5, 3, and 1. Those are whole numbers. Okay, so this is a polynomial function, and this would be a degree 5 polynomial. Okay, again, the degree is always the largest power of x that we see. The next one, g of x equals 4x squared minus 3x to the negative first power. Okay, so that's not going to be a polynomial because every single power of x is not a whole number. -1 is not a whole number, right? So again, a whole number is a number of the form 0, 1, 2, 3, 4, right? You can't have any negatives. You also can't have any fractional powers, okay, like what we saw right here. Okay, those are not polynomials. Okay, now when it's not a polynomial, again, I don't talk about the degree. It was not a polynomial to begin with. Okay. We're going to do lots of things with polynomials in the later part of chapter 3 there. Okay, so let's see. Problem 20 is where I want us to solve each equation. Okay, let's see. We're going to talk about quadratic equations here in quadratic functions the rest of the way for this chapter. In part A, I have the equation x squared plus x plus 5 equals 9x minus 7. Okay, so if I get everything onto the left, subtract 9x and add 7, I get x squared minus 8x plus 12 equals 0. Okay, that would be an example of a quadratic equation. And a quadratic equation, you have an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers. A can't be 0, though. So in order to call it a quadratic, you need to make sure that the squared term is included. Okay? Now, the first thing that you always want to think of whenever you're solving a quadratic is if it factors. Factoring by far and away is going to be the easiest, most efficient method. Okay, now not all equations factor, so there is more to know with this. Okay, let's see. So this one's going to factor. If I set up the two factors there, I got x and x, and then need two numbers that multiply together be 12, and then when you add them together, you get -8. Okay, well, that's going to be -6 and -2. So I can check that by foiling this back, and I should get the line right above. So x times x, that's x squared. -2x minus 6x is -8x. Right, and then -6 times -2 is 12 at the end. So that's good there. And then if I set each factor equal to 0, x minus 6 equals 0 means that x is 6. X minus 2 equals 0 means that x is 2. Okay, so those would be the two answers. By the way, whenever I have a quadratic equation, which is what I have here, I will always have two answers. That will always happen. Okay, now one of the really important things that we're going to talk about, kind of midway through chapter 3 here, is what's called the fundamental theorem of algebra. Okay, the fundamental theorem of algebra is kind of like the big result that we have in algebra. Okay, and it just says that if you just look at the degree of the polynomial, I have a polynomial here. This is a quadratic equation. A quadratic equation is an example of a polynomial. And if you just look at the degree of the polynomial, here the degree is 2, that'll tell you how many answers you're going to have. Okay, so I can know that I'm going to have two answers. Okay, and whenever I have a quadratic, I will always have two answers because I got a degree 2 polynomial. Okay, part B. I want to solve the equation given by 3x squared minus 15x minus 42 equals 0. Okay, so there's a quadratic equation. If I divide both sides by 3 goes into all three of these numbers evenly. Right? Then I can make the numbers a bit nicer than what they are. So I got x squared minus 5x minus 14 equals 0. And by the way, look for those times where you can make the numbers easier than what they are. Because all the people, try to factor this guy here right at the beginning, and that, if you're doing that, you've made the problem more difficult than what it needs to be. Okay, so look for those times where you can divide both sides by a number and make the numbers easier than what they are. Okay, so like with this, I got x and x, that's x squared, and the factors of 14 would be 7 and 2. It'd be a minus 7 and a plus 2 for the signs. So if I check this, x times x is x squared. 2x minus 7x is minus 5x. And then negative 7 times 2 is negative 14 at the end. Okay. And then set each factor equal to 0. So x minus 7 equals 0 means that x is 7. X plus 2 equals 0 means that x is negative 2. Again, these two numbers there would be the two solutions. We try part C. X squared minus 49 equals 0. In this problem, we have what's called the difference of two squares. Okay, so I got two squares. Right, 7 squared is 49, so I got two squares that I'm subtracting, and I get 0. That's going to factor nicely as x plus 7 times x minus 7. So if I FOIL this back, the middle term should be 0. X times x is x squared. Negative 7x plus 7x, that's 0 in the middle. Right? And then 7 times negative 7, that's negative 49 at the end. All that's equal to 0. And so I get x to be negative 7 or x to be 7. That'd be the two solutions for that one. Okay. Now that works great in part C, because it's factored nicely. Now in part D, if I have x squared minus 50 equals 0, that's not going to factor nicely. Okay. Because two numbers that multiply together to be 50 that are the same, I don't know what those numbers are. Okay. So if we add 50 to both sides, we have x squared equal 50. Then take the square root of both sides. Now, whenever you take the square root of both sides in an equation, you always have to tack on a plus minus onto the right. Don't forget about that necessary thing. Okay, so x is equal to plus or minus root 50. Root 50 breaks down as 25 times 2 is 50, right? The square root of 25 is 5. So x would be plus or minus 5 root 2. That'd be the two answers there. Again, you always have two answers whenever you're solving a quadratic. Okay? Now, I could do the same thing over here. I'd say x squared equal 49, take the square root of both sides, so x would be plus or minus, the square root of 49 is 7. Right? So 7 and negative 7 would be the two solutions there. Okay? In part E, we have x minus 5 squared equals 18. So that would be a quadratic. Now, if I were to, simplify this, I could write it so that I've got, something of the form ax squared plus bx plus c equals 0. I'm not going to do that, though, because I'm squaring the left side. So let's go ahead and use the square root property next to get rid of the power of 2. The square root of x minus 5 squared, that'd be x minus 5. And that's equal to plus or minus, don't forget about that, you got the square root of 18. The square root of 18 is the same as 3 root 2, right? 9 times 2 is 18, the square root of 9 is 3. So then if I add 5 to both sides, x would be 5 plus or minus 3 root 2. Now, I would say that if you're just solving an equation, and it's not directly related to some story problem or something like that, go ahead and keep your answers in exact form. That's how the book will want it also. Okay, so there's no reason to go to the calculator and type this in, Now, if somebody's asking you for a measurement, that's different, okay? you're not going to tell them, oh, it's 5 plus root 2 inches. Okay, no. You're going to give them the decimal number, whatever that is. Okay. Part F, we have 3x plus 7 squared equals 20. So if I take the square root of both sides there, 3x plus 7 is equal to plus or minus the square root of 20. The square root of 20 is the same as 2 root 5. So we're solving for x. Let's go ahead and subtract 7 from both sides. I got 3x equals negative 7 plus or minus 2 root 5. And then divide by 3. So the answer would be negative 7 plus or minus 2 root 5 all over 3. Okay. Now in these two examples, we're using what's called the square root property. Okay. So in all, there's 4 methods for solving a quadratic that we need to know. They're factoring the square root property, completing the square is another method, and then using the quadratic formula, that'd be the last method. Okay. So in the next video, we'll pick up with problem 21 there.